right then. Maybe it doesn't affect it because I'm watching the Facebook one.
Oh yeah?
Yeah, and there's a section where it like stops for a bit.
And we're live, Nish. Hey Sam, how you doing, buddy?
Yeah, good guys. How are you?
Good, buddy. Good. Did you catch action this morning?
Sorry, say that again.
Did you catch Mr. Jackson this morning?
I didn't this morning. No, I went out for a run. I had to enjoy the beautiful blue skies that are there, so went for a quick run this morning and felt absolutely knackered for it. But there we go.
So how when you were doing the gymnastics, how often did you actually have to train in them?
I trained every day. So every morning before school, Monday to Friday, an hour before school, and then 4 hours on a Saturday, and then the evenings Monday to Friday for 3 or 4 hours.
That's crazy. That's absolutely crazy.
Yeah, my dad was my coach, so I didn't really have much choice, to be fair.
He must be a patient man. I'll try and teach my children some things, especially during this time together. And I just like, wow, to really, really coach someone through something, especially when it's the basics, when they're really, really young. It's just, it's really, you have to be dedicated.
Yeah, it's difficult, yeah. But I think with my dad's, luckily my dad had a good career himself in gymnastics, you know, he was in the Olympics and stuff like that. So with his pedigree, I sort of just followed on. My two older brothers as well. So.
Your dad went to the Olympics?
Yeah, he was in Moscow and Los Angeles. Oh, I hope he's not listening. Can't remember which ones he did. I think is that 76 and 80 or 80 and 84. Yeah, I'm sure if he's listening, he did quite well.
Brilliant. Well, I'm going to look it up afterwards. I'm definitely going to look it up. So you ready for today's session, buddy?
Yes, mate, raring to go. We're just going to follow on from what we did on Monday. So sequences, a bit of Fibonacci, geometric, and quadratic.
Wonderful. All right, well, I'll just give you a brief introduction. Thank you. Thank you again to everyone who's tuning in. Thank you very much for the teachers, obviously, for helping out. And just remember that this is a short 20-minute piece to kind of boost, remind, help people while everyone's, staying home, staying safe, and protecting the NHS. So hopefully this just gives you a little bit of something to kind of hook learning around or in your day, especially starting with the morning. Really, really lucky to have Sam Winch, a really, really experienced maths teacher with us now, who's going to be taking us through a range of items. Are we going to be using the visualizer today, Sam?
Absolutely.
This is actually this is going to be my new favorite online learning tool. As soon as Amazon get through their their delay and their back catalog, I'm getting me one of those.
Yeah, 100%.
Buddy, it's all yours. Thank you so much.
Cheers, Leon. Cheers, guys. Again, I hope so far what you've seen with PE yesterday and maths on Monday, you've enjoyed. Today we're just going to carry on, as I said earlier, from what we did on Monday with Fibonacci, geometric, and quadratic sequences. So, Nish, if you could share my screen, please.
All right.
And I'm just going to present. Okay, so as it's just loading up, you can see on the screen a quick breakdown of sequences. So you've got linear, which we covered on Monday. There you're looking between a GCSE level 3 and a GCSE level 5. Of course, a linear sequence is where the number is consistent. So it goes up in the same pattern each time. And again, we might cover a little bit more of linear on Friday. GCSE level 3s were Fibonacci and geometric. That's what we're going to focus on today, finishing with quadratic sequences, which you'd only find on the higher paper because that's aimed at grade 7 to grade 9. Okay, so quick recap on Fibonacci. I think I might have put this one on the screen on Monday, but it's always good to recap. So a Fibonacci sequence is where you add a number or you subtract the numbers together to find the previous number or the following term. So here on the screen, you're missing term 1, term 2, term 3, but you'll be given the 4th term, the 5th term, which is 28 and 43. So with those two terms, we might need to break it down and find that the 3rd term, of course, is 15, because 43 minus 28, well, let me use my little pointer here. 43 minus 28 will give us 15. And then, of course, we'd follow on from that by saying 28 minus 15 gives us 13, and 15 minus 13 equals 2. So the question says, show that the first term is 2. If you've shown any subtraction, and here is actually from the mark scheme, here's what they want to see. If you've shown the subtraction and you've shown the numbers 15, 13, and 2, then you'll get your 2 marks. And that question, as you can see there, is valued at 2 marks. Okay. So that's Fibonacci sequences. I'm going to go through using my trusty visualizer. I'm just going to do 3 or 4 examples on the screen now. I'll just zoom in a little bit for you. And we'll just zoom in there. Brilliant. So nice and easy. We'll start off with 3 and 6. Of course, the next number will be 9. So I'm just adding the 2 together. Here we've got 2 and 7. Of course, again, we'd have 9. We'd look back at 7 and 9 to give us 16. I'm just going to see if I can change the colour a little bit there, get it a bit brighter. Apologies. Right, good. 1 and 3 together would give us 4, and then of course 3 and 4 would give us 7. Onto these questions down here now, you see that they're missing the they're missing the second term. So nice and simple, you can do 2 things. You could either go back and say, well, 11 minus 3, or subtracted by 30. Sorry, I just questioned myself then. 14 add 5 add something equals 14. Again, you could go back on yourself. 14 minus 5 is 9. Let's check. 5 and 9, does that make 14? Yes, it does. And then we carry on from there. So we've got 23 and 37. Okay, we'll just do one more. We'll go straight to the bottom, I think, actually. Slightly harder one, perhaps. What's 10 subtracted by 2.5? 7.5. Does that work? Yes, it does. And 7.5 out of 10 is 17.5. So nice and easy from Fibonacci's. There's a couple of examples that I've done for you, and I'll be giving you a task later on today to complete. Of course, it's optional, but if you'd like to have a go at Fibonacci, you can. Now, moving on to geometric sequences. Again, it's looking at a grade 3. The geometric sequence, of course, is what the term multiplies by each time, or perhaps what it divides by if you're given the third and fourth term and you're asked to find out the first and second. So here on our screen now, we've got 8, 32. What is term 4? Now, we could find out what term 3 is, and then, of course, that would use that geometric sequence each time to find out what the fourth term is. So what do we times 8 by to get to 32? Now, the opposite of multiplication, of course, is division. 32 divided by 8 would give us 4. So the geometric progression here is 4. But the question is, and they'll give you 2 questions in terms of geometric sequence. They could ask you, what is the geometric progression? Well, the geometric progression is 4 because it multiplies by 4. Or they might ask you to find the fourth term or the third term or the fifth term. Here we've got 8 times 4 is 32. 32 times 4 is 128. And then 128 times 4 is 512. And just a little tip for you. I will actually, here's a little tip for you. So if they ask you for the fourth term, which they often do, of course, you could multiply 8 by 32. You could multiply the first and the second term together. In this instance, 8 times 32 would give you 256. And then to find the fourth term, if you just times it by 2, double it, as you would when anytime you times it by 4, you'd get 512. That's just another method that perhaps you see, and I'll maybe demonstrate that one at a later date. But here we go. Let's do a couple of examples again. Back to the visualizer, and maybe I'll demonstrate that example that I just spoke about. So you've got the first one, 4, then 12. What is the geometric progression? Of course, just times in by 3, so that would give us 36. Next one, again, 9 times what makes 27? We again times it by 3. And again, if you're not sure, we don't want to just guess, we should do 27 divided by 9, which would also give us 3. And here you'd have 81, and you'd have 243. And of course, live television as always, I'm sure I won't make any mistakes, but I can never be too sure, actually. You never know. 5 and 25. Geometric progression here is times 5. Therefore, the next one would be 125 and 625. Slightly different again, similar to Fibonacci. Here, we're not given the first term, but we're given the second and third term. 9 divided by 3 is 3. So therefore, the geometric progression here is divisible by 3. 3 divided by 3 is 1. Here, we're looking at 64 divided by 16, which is 4. So 16 divided by 4 is 4, and again, 4 divided by 4 is 1. Slightly different, and this would be the difference where you may get, instead of GCSE level 3, geometric sequences, sorry, may then progress to a GCSE level 4. Why? Because it's a decimal. So if it's a decimal or a fraction, they may look to increase the grade ever so slightly. What are we dividing by here? Now it's 0.5 divisible by 0.5. If that's the case, therefore, what do we divide 2.5 by is 0.5. 2.5 divided by 0.5 would give us 5. And then what by 5, here you'd get yourself 10. So 10 times 0.5 is 5, 5 times 0.5 is 2.5, and 2.5 times 1.25 is 0.5. Okay, so there the geometric progression for the bottom one is 0.5. Okay, back to the PowerPoint. I hope I'm not going too quickly for you guys at home, but you will be given tasks to do, like I've already said, and we're going to go in about 2-3 minutes and give you a 60-second fast recap round of everything linear, geometric, Fibonacci, and even a quick recap of quadratics. But that's what we're moving on to now, quadratic sequences. So quadratic sequences, as I said earlier, only features on the higher paper, GCSE. And again, they can ask you 3 types of question. So first of all, they might ask you to write an expression in terms of n. They might ask you to complete the sequence. And then they may also ask you to find a term. First and foremost, what is a quadratic sequence? Obviously different to linear because the initial sequence isn't consistent. So whereas a linear sequence, you might have 3, 6, 9, 12, it goes up in 3s every time. Quadratic sequence is different because the first sequence, the first line, if you like, doesn't have a consistent pattern. However, the second line would have a consistent pattern. So if we look at the demonstration here at the bottom, you've got the sequence 9, 13, 19, 27. They don't go up consistently. 4, then it goes 6, then it goes 8. However, if you look at the second line, well, actually, it goes up by 2s, by 2s, by 2s. Now, the one written rule when you're working with quadratic sequences is that the second line, whatever it goes up by, you must then divide it by 2 to get the first part of your answer. So to get an squared would be the first part of the answer. And I'm going to give you a demonstration now as to what this all means and break it down for you. Just a couple of examples here that I've put on the screen as what type of question you might get. So the nth term of a sequence is 2n squared plus 4n minus 1, and they would ask you to perhaps find out the 10th term or the 100th term of that sequence. These questions are very similar, in fact the exact same as a linear sequence. You just replace the n with whatever term they're asking for. So here you replace the n for 10, 10 squared we know is 100, 100 times 2 is 200, and again you plus in 40 because n is 10, 10 times 4 is 40, minus 1, etc. So let's move on to a GCSE style question. This was taken from the AQA Example GCSE paper in the last 3 years, sorry. And here's the question they said. Work out an expression for the nth term of the quadratic sequence 2, 17, 40, and 71. And they want you to give your answer in the form an squared plus bn plus c. So I'm going to now do a demonstration for you exactly how to break that down. And we will switch back to here. I must admit, I just want to get my lighting a little bit better. Okay, so we've got 2, 17, 40, 71. That's the sequence. Now, I know straight away that it's a quadratic sequence. Why? Because it doesn't go in a consistent sequence each time. So first and foremost, in fact, what I want to do here is an squared, little box, bn, bn, add c. Okay. Now, it might not be add, it might be subtract, but of course we know from the question, if I flip back through, we know that it's add because they've given us the form. So here I can put my my addition signs in here. So the first part I want to work out is what is the second difference each time? Now, we know this one goes up in 15. We know that this one goes up by 23. And of course, we know that this time it goes up by 31. Right, so the first line we know isn't consistent. Let's try on the second line, where we've got 8, and here again, we've got 8. Brilliant, so that can go into my an squared box here. But we said that the second line must be divisible by 2. So 8 divided by 2 will give us in here 4n squared. So there's the first part of my answer. Moving on to the second part of my answer, what I will do here now is write down the squared numbers, because we're using squared here, so we're going to 1, positive 1. Difference there is, of course, positive 4, and here it's positive 7. So to find out what bn is, what is the difference each time here? Of course, the difference is -2 to 1 is positive 3, positive 1 to positive 4 is, again, positive 3, and positive 4 to positive 7 is positive 3. So therefore, we can replace bn with 3n. And finally, and here I'm going to give you 2 methods to find out c. There's one that's a lot easier than the other. However, I do think it's really important that you get different methods on how to work out questions. And you guys at home can choose which one you fancy more than the other. My method would be, well, if the second difference is 8 each time, then I want to find out the previous number here. So if I'm going up by 8, I might go down by 8 here, which means the difference in the first round would be 7. Well, what's 2 minus 7? Of course, the answer is -5. That's 5. Now, I want to give you another example, and that would be if the other example would be, of course, if I just simply add 4, add 3, that gives me 7. How do I get from 7 to the first number in the sequence? From 7 to 2, you take away 5. So again, quite straightforward. What I have realised is that in the form here, give your answer in the form n squared plus bn plus c. Of course, we look at the answer. It's not n squared plus bn squared plus c. It's 4n squared plus 3n minus 5. So I'll be ringing the AQA exam board and speak to them about that. Okay, so let's move on to some more examples. Complete examples on the board for quadratic sequences. So I've got 2 on my visualizer here now. We've got the sequence 1, 4, 9, 16, and 2, 5, 10, and 17. Let's have a go at these ones. I think we've got about 3-4 more minutes, and then we can go through a quick recap on what we've done so far this week. So the first one, actually really straightforward. What's the difference each time? We've got 3, we've got 5, and we've got 7. So therefore, it's 2 each time. We know that we divide that by 2. So as we know it, that the answer is just n squared. Let's just double check. But if I put my n squared numbers up here, how do we get from there to there? Well, actually, we don't have to do anything. So, I don't know, people might think, well, plus 0 or minus 0. Let's just leave it as n squared. That's the question 1, n squared. Have a look at this one. We go 3, 5, and 7. Again, a difference of 2. So the first part of our answer is n squared, because we've got to divide that by 2. And then if we put our squared numbers up here, how do I get from that to the sequence? Fortunately, this one, again, is relatively easy. We're just plussing by 1. Now, as you saw in the first question, slightly harder. That would be looking at more a GCSE level 8 question. This would probably be a GCSE level 7 question, because it's only got an squared plus b as opposed to an squared plus bn plus c. So it's slightly easier, these ones, but I'll still be looking for you guys to be comfortable with that in showing the square numbers and the second difference. Okay, back to our PowerPoint 60-second recap. We've got a couple more minutes live on screen. I want to give you a 60-second recap and then throw out in 60 seconds 7 questions for you to answer, A, B, C, or D. So 60 seconds, a linear sequence is a number pattern which increases or decreases by the same amount each time. And there's an example for you. 10, 6, 2 minus 2 equals minus 4n plus 14. Geometric sequence is a sequence of numbers which is found by multiplying the previous one by a common number. So again, what do you times by to get to the next one? Here, the geometric progression is 5. Fibonacci sequence, the next number is found by adding up the two numbers before it, often starting with 0 and 1. And there's the common Fibonacci sequence that we're all familiar with. And a quadratic sequence is a set of numbers in which the second difference between each consecutive term differs by the same amount. And an example there would be n squared plus 3. So with the last minute, what I'm going to give on your screen is 5 or 6 questions. I'm going to fire them out. You've got 5 seconds to have a go at the answers. Of course, you'll be given a task to complete at the end of this tutorial. Question 2, what is the nth term of -2, 5, 12, 19, and 16? You've got A, B, C, and D. What is the nth term of 2, 2.5, 3, 3.5, and 4? Again, A, B, C, or D.
I so wish I could take part, Sam. Like, I'm literally just like, why is there letters? Why is there so many letters?
Well, I'm sorry that I'm flicking through so quickly, to be honest. There's 3 more questions. But we can,
even if you gave me a week, unless you gave me a teacher by my side, it wouldn't make any difference, buddy.
Okay, fair enough. Well, what I'll do for the guys at home, I will repeat this consolidation on Friday, and we can maybe break it down. I'll also give you the answers to the questions. But finally, I want to finish with this question to take away. And again, you can send in your answers to the live page. But the question is, I'm a 3-digit number. My tens digit is 6 more than my ones digit. My hundreds digit is 8 less than my tens digit. What number am I? So, Nish, if I could come back onto the screen, please.
All right.
And you're on, buddy.
So that's the final question. I'm a 3-digit number. My tens digit is 6 more than my ones digit. My hundreds digit is 8 less than my tens digit. What number am I? It would be great to see if we could get some people emailing in their answers. I think we might have had a few on Monday, so a few more today. Get a bit interactive and see what you guys think at home. Other than that, that's the end of today's tutorial.
Thank you so much, Sam, buddy. Really, really appreciate it. That was super calm. Yeah, just love listening to your voice, man. I just wish I knew a little bit more about maths to actually join in with the session. Yeah, and we really look forward to having you again over the next couple of days.
Cool. Cheers, guys. See you later.
Thank you so much, Sam. God bless you, buddy.
Bye-bye.
Okay, Nish. So we're going to go back to the wonderful templates, and neither of us is sharing our screen when we tell everyone to always share their screen. Yeah, that is school. I was going to say schoolboy, schoolgirl era, but then you never know what you can say when you're live. Imagine that if you're banned from saying certain words. I just got a message from someone watching saying, please remember to mention stay home and stay safe. Can you imagine if someone actually had taken this stream and they've gone off to a park and they were just kind of like, yeah, I'm doing my exercise and my GCSE revision at the same time. So yeah, just obviously I'm taking for granted that everyone's at home watching this, but yes, please stay home. What is the phrase? Stay home, save protect the NHS, save lives?
Something like that.
Yeah, we might have the logo in the bottom corner as well, just kind of tying in with why we're actually doing this.
We should.
Brilliant. So if that goes nice and live, do you want to tell us what some of the information here is, Nish? Just to put you.
All right, cool. So this is the optional task for students and their parents if they want to help and get involved. For maths, so there are 4 questions, and they're all showing you the first 4, or 2 of them are showing you the first 4 terms of the quadratic sequence, and you have to write down the next term. The third question is the nth term of the sequence, and you have to work out what the 3 first terms are. And then the last one is a quadratic sequence, and you have to work out what the value of the 6th term is.
Could you do them, Nish?
Probably not. I could, if I really tried, then maybe I guess I could do the first 2.
I'd be straight on YouTube looking at 100 tutorial videos before I got there.
That's why we have Sam.
Yeah, that's why we have Sam. Imagine that. We were the math tutors. That's going to fail completely. And over on the left, guys, what we're going to do at the end of the day is there is a website there, Stream School Guide Core.xyz, and you sign in with the code ME123. And essentially all the items are there for you from anything from these lessons. They're all going to be in one place, and they're organized by subject. So obviously they're all going to be there on Facebook. They're all going to be there on YouTube as well, but we're just going to be tidying them up a bit to do X, Y, and Z, and having all the resources in one place. Just a third option if you want it, but obviously Facebook comments and YouTube is your first port of call for those items. Brilliant. Well, thank you very much again for joining us, and we will be back again in, what's that, about 16 minutes each, or 15 minutes?
Yeah, 15 minutes.
All right, brilliant. I will speak to you then, my dear.
Perfect.